Okay, welcome to this video on running some starter code in Domino. We are going to take a look at the Tumblr case. We're starting here from Canvas, and we're going to connect to Domino. So we're going to just follow this link, darden@domino.tech, and I'm already logged in here. We're going to go ahead and look at the projects that I collaborate on. The data science faculty have shared the Tumblr project with me. So this is session 3 Tumblr. We're going to click into that, and we're going to see our first step in the process once we've logged in. I'm going to open up a Word document here real quick, and we're going to be working with this acronym. So what does FLAP stand for? This is fork. That'll be our first step. LA, this will be launch. Then P, this will be play. And then S will be stop and commit. Roughly speaking, these steps will first make an individual copy of the project that we can work on as an individual. Then we're going to launch the notebook that has the starter code in it. Then we're going to start playing the code. We'll also show you how to add new code to our starter code. And then when we're finished and we like our results and we want to stop the session that we've got going, which is running the code on an AWS virtual machine, we will go to session and then stop and commit the codes. The commit part will save the changes we've made. So we'll come back to this acronym FLAPS. It will be something we use throughout the course when working with Jupyter in Domino. Okay, so our first step is in FLAPS is fork. So we're going to fork the project. My username is LichtendahlC. And now I've got, let's go back to the pinwheel here, and you can see the projects I have that are mine. I've got a session 3 Tumblr that is a version of my own. So then we'll go into this project, my own version, and we are going to go ahead and then go to, if we want to see the assignment sheet for the session, here's the assignment sheet, and this looks just like what you'd normally see on Canvas. The topic and the case, so we'll have you read the case. There's a spreadsheet that's available if you want to go ahead and take a look at the valuation model that the forecast your starter code creates will be useful in. So we will plug in forecasts from our starter code eventually into our valuation model that sits in this spreadsheet. The raw data is in the CSV, and our starter code is in the IPython notebook, Tumblr.I, PY, and B. And there's some reading here in the Practical Time Series Forecasting book with R, and we'll be flipping over to that. That starts on page 93. We'll be looking at this model, and then on page, flipping forward to the multiplicative trend model, we'll be taking a look at oops, I think I went too far. Let's see. Let's get back to that. Excuse me. Went a little too far here in this book. We're on page 90, Advanced Exponential Smoothing Methods. That was the edit here. Okay, so here's the additive trend model. Okay, so here's the multiplicative trend model. It's on page 94. So just these two pages, and then one other page we'll be taking a look at. So now back to Domino. I'm going to go to Files, and you can see these files. Here's the case. Here's that spreadsheet if you want to open it up from Domino, although that would be odd. I think you want to do that locally on your own machine. Here's the data set, which we'll be reading in using the starter code. So what I'm going to do now in FLAPS is, so I've already forked the project. We're here in our acronym FLAPS. And we're ready to launch the notebook. So we click on the notebook, and you'll notice there's up here in the upper right hand corner, there's launch notebook. And so now our AWS machine is starting up in the background. Domino is facilitating that connection to a virtual machine somewhere in a data center. And now we've got a live notebook. So what we're going to do is we're going to start by loading the library called Forecast, which is the package in R that is going to help us fit these exponential smoothing models using the function called ETS. So I'm just going to go ahead and hit the play button, and this, or you might call this the run cell button. So that's our third step here in our acronym FLAPS, the play. So this is how we play cells or run cells in our, and notice that it was a starred out cell and then it turned into a 1, which means it was running and then it eventually finished. So now this package is loaded and we can start using it down below when we call functions like ETS. We know that ETS is a function in the forecast package, but if you didn't know that, you might want to go over here and just do something simple like forecast in R. You do forecast in R, normally what comes up is a PDF, which is available for any package that's in the R universe, and you can read about who wrote it, what its purpose is, what its longer title is, and then what are all the functions that are inside of it. So you see ETS down here, and if you just click on this link, you can get to the ETS function. What are all of its arguments? There are a lot of arguments here. We're only going to use a few of them. Then there's descriptions of all these arguments. This is not unlike what you see when you look for help in Excel on a function. So that's one way to do this. I'll show you another quick way to do this. So if you add a cell down below, this insert cell below is this little plus button. You can do something really quickly with a question mark. So if you type question mark ETS, you know one of the names of the functions in the forecast package. And then if you hit play here, or the shortcut is Control Enter, you can get the same output that's in the PDF file to appear here in the Jupyter Notebook. So now you've got the function and all the arguments that it takes and a description of these arguments in the function. Okay, so that can be a little overwhelming. We're going to delete this cell, so you can just go up here and say cut selected cell, so now that's gone. Alright, so now in this next cell, there are 4 lines of code in this next cell, and when we press play here on this cell, it's going to run all 4 lines at the same time. So what do these 4 lines do? We read in the data, so this is going to read in the CSV data into the Tumblr data frame here, which we've called Tumblr.data. Then we're going to turn the column called, actually, you know what, let me make another cell, and I'll take these things down below into a separate cell and insert one more cell in here and show you something you may have already seen before, which is, let's just take a look at the head and the tail of the Tumblr.data. So we're going to load in the data. Okay, so that ran very quickly, and then we're going to take a look at the head and tail of this data set. So we can see that we've got 3 columns in this data set, and we've got 38 rows. So that's good to know. The next step is we're going to turn just the people worldwide column, so that's this first column, we're going to turn that into a time series. And then we're going to make a quick plot of that time series by month, because these data are monthly. Alright, so we're going to run this, and we get from months 1 out to months 38 a time series in millions of people worldwide traffic at the Tumblr site. Okay, so we've already got a sense that we've got some kind of increasing trend, and our next step is to figure out what kind of model might help us best fit to these data, and then forecast into the future what might happen with Tumblr traffic over the next many years. This is going to help Yahoo think about a valuation for the company. So here's the 3 models we're going to fit. We're going to fit exponential smoothing models. The first one is going to have an additive error. That's the first A. an additive trend, that's the second A, and then no seasonality. We don't see any evidence of seasonality here as we roll through the months. We do see some evidence of a trend. This is a trend upward. Maybe that's an additive trend. It might also be a multiplicative trend, so that'll be the second model we fit. When we fit a multiplicative trend, we're also going to use multiplicative error, and what that is going to do is make the errors relative, or another way to say that is in percentage terms, so that when the level gets higher, the errors get higher if it's on a percentage basis. If we use additive error, the errors are absolute. They're always the same size no matter what the level is. So when we're down here low at 20 million people, if there are errors around some kind of center line, those errors are not going to be any bigger or smaller than the errors we see when the trend or the level gets quite a bit higher, up around, say, 120 here. And I think we can see that there's very little volatility down here, but as the traffic grows to a high level, we start to see more variability. So it may be appropriate, just from a visual inspection, to be using multiplicative error. But we'll see. We'll take a look at how these models fit and what kinds of forecasts they make out into the future. And this is going to be mainly a visual exercise. We're not going to be looking at too many statistics that would either convince us that this first model is the best or one of the other models is the best. This is going to be somewhat of a subjective call because we're making some pretty long-term forecasts from this 38-month data set. Okay, so we're going to run these three models, so they run really quickly, and then we're going to take a look at what the ETS function would do if we didn't tell it what the model is. And when we don't tell it what the model is, it searches through a very large number of models, and I'll show you in the book here the number of models that it searches through. What it does is it tries additive and multiplicative error, so A or M, and then it does it for 5 trends and 3 types of seasonalities. So what this produces is there are 15 possible models here for additive error, and then there are another 15 when there's a multiplicative error. So that produces a universe of 30 different ETS models, or exponential smoothing models. We've already fit 3 of them. Now what we're going to do with this ETS without any specification of the models, let it search through all 30 of them with no restrictions, because sometimes it will not automatically test an additive error with a multiplicative trend, but we're going to go ahead and let it do that. And we're going to also search through all multiplicative trend models. So that's this cell here. And what it spits back is the optimal model that it's finding for the time series above, these 38 months of traffic at Tumblr, is that you should use a multiplicative error, you should use a multiplicative trend, but with the caveat that, or I should say with the additional specification that the trend, the multiplicative trend, is damped. And I'll say in a second what that means. And then we're using no seasonality here. So we're using a damped trend. So that's this model up here. This third model, which we specified, is what the model without any specification spit out as its best fit model. And so this is a multiplicative error, multiplicative trend, and we've turned on the dampen feature here with this damped equals true. And so what does that mean? You'll see in the pictures below what a damped trend means. And so just quickly, what is a multiplicative model with multiplicative error? We'll just go to the book here and show the model form for the series with a multiplicative trend. This is going to take a level, and instead of our additive model where we took the level and we added some number of little trend pieces forward, so if we're going to forecast out K periods, whatever our slope is, we would multiply that slope by the k periods forward. This would give us an additive trend or a straight line forecast into the future. Instead, we're going to do something that's exponential. We're going to take our slope or our trend and we're going to raise it to the power k, however many periods we want to go into the future. And then we're going to multiply it by some level, which is like our intercept, or where we start.